Hello friends, at the last part we are going to discuss some of the cases of complexity of an algorithm. The cases of complexity refers to three different ways of measuring the time complexity with respect to different inputs given to the same size of the algorithm. So, it can be defined in three forms, that is the best case complexity of an algorithm, the worst case complexity of the algorithm, or an average case complexity of the algorithm. So let's start with the best case. In this, the complexity of solving the problem for the best input, that is, it takes the minimum number of steps to complete an algorithm of size n. Similarly, the worst case complexity takes the complexity of solving the problem for the worst input, that is, the maximum number of steps to solve an problem or to solve an algorithm of size n. And the average case complexity is the complexity of solving the problem on an average. This complexity is only defined with respect to a probability of distribution over the inputs. That is, we can summarize as the best case complexity takes the minimum number of steps to solve any problem. The worst case complexity takes the maximum number of steps to solve any problem of same size. That is, if the size of a problem is n, the best case takes minimum number of steps to solve the same problem. The worst case takes the maximum number of steps to solve the same problem. And the average case takes probability number of distributions or probability number of steps to solve the same problem. Next, we will see the time and space trade-off. We normally want an efficient algorithm, which we have already discussed that an efficient algorithm is, it should take the minimum number of time for execution and it should take less memory space in the computer memory. But we in normal cannot find the perfect algorithm with the both components in some of the cases. So, to overcome this situation, we have the concept of time and space trade-off. It is a situation where the program execution time can be reduced at the cost of more memory, or the memory can be deducted at the cost of slower program. That is, for getting an efficient program, either we can increase the execution time, but at the other end, we have to reduce the space, that is memory space, or we can increase as much as memory space, but we have to reduce the execution time or your time complexity of the algorithm. So this is your concept of time and space trade-off, in which both are adjust or both are coordinated to find an efficient algorithm, either by increasing the execution time and deducting the memory space, or by decreasing the execution time and increasing the memory space. So this was your end to your first chapter. Thank you all.